Okay, this video is on even and odd functions. So let me start by giving you the definition of an even function. So if a function f satisfies this condition, which is f of minus x is equal to f of x for every number x in its domain, then f is called an even function. Okay, so let me give you an example so this definition makes more sense. Consider this function. So let it's let f of x be x squared. Now let's apply this and see what will happen. Let's work out f of minus x. So if we work out f of minus x and that turns out to be the same as f of x, then that means that this function is an even function. So for this case, f of minus x is equal to minus x squared, and this is equal to x squared, which is exactly the same as f of x, because we know that f of x is x squared. So basically all you have to do in order to see if a function is an even function, you should apply this and see if this works, which means that you need to substitute minus x into the function, and if that is equal to f of x, then that means that this function is an even function. But there is one more thing, which is an additional fact, which is about this concept geometrically. So because there is a very nice property that even functions have, and that is, so let's just consider just our example, which is a quadratic function. So f of x is equal to x squared. So the graph of that is this. So this is a quadratic function, and the interesting fact here is that if a function is an even function, then whenever you consider the part of the graph that is for the positive x values, and in an even function always the reflection of the positive side of the graph, the reflection of that through the y-axis tells you that this is an even function. So for example, in this case, you can easily see that the positive part of this graph reflected through y-axis is this, and because that's a rule. So if you were to reflect the positive part of the graph and then you get the same thing, then that means that this is an even function. So to just to put that more rigorously, we can say that basically, let's say, yeah, so I just saved a bit of time by just writing all of this down. So basically, to put that more rigorously, the basically the geometric significance of an even function is that its graph is symmetric with respect to the y-axis. So basically, in simpler language, this means that if we have plotted the graph of f for positive x values, then we obtain the entire graph simply by reflecting this portion about the y-axis. So what does that mean? So let's pretend that we don't know how to draw the graph of a quadratic function. But we know that, let's say we are told that a quadratic function is an even function. Now, by considering this fact about even functions, that the entire graph can be basically found simply by reflecting the positive portion about the y-axis, then that simply means that if we, because this is the positive portion of the graph, so if we just reflect this through the y-axis, then we get the entire graph. So of course, everyone knows that what is the graph of a quadratic curve, but this is just for the sake of example. And yeah, it's a very, very important fact and property of even functions. Now I'm going to uh, do the next bit, which is about odd functions. So now this time, again, the definition, we start by the definition, which is if f satisfies f of minus x is equal to minus f of x for every number x in its domain, then f is called an odd function. So again, let's just consider an example. So let f of x be equal to x cubed this time. Now, let's, apply this and see what happens. So let's see what is f of minus x. So f of minus x means minus x cubed. Basically, we substitute minus x into this function. And minus x cubed is minus x cubed because we are raising a negative number to an odd power. That means the final result is going to be negative. And this is equal to minus x cubed, right? So if we negate x cubed, then we get minus x cubed. And also we know that x cubed is equal to f of x. So we have minus f of x. And this is exactly what is written here. Basically, this satisfies this condition, and that means that x cubed is an odd function. So, yeah, the key takeaway here is that if you have an even function and you substitute minus x into that, you will still get the same function. It doesn't matter. It doesn't make a difference. Like here, as you can see. Whereas if you have an odd function and you substitute minus x into that, then this time you are going to get a negative version of the function. So now, again, I'm going to basically show you the geometrical significance of odd functions as well, just like when I showed you all the even functions. So now if you want to consider the geometrical property of odd functions, that is the graph of an odd function is symmetric about the origin. So if we already have the graph of f for positive x values, we can obtain the entire graph by rotating this portion through 180 degrees about the origin. So I want to show you even a simpler explanation of the geometrical importance of odd functions. So let's consider our example that we had above, which was this function, and we concluded this is an even function. Sorry, an odd function, which is x cubed. This is the cubic graph. So again, let's take the same approach. So we know that this is the shape of a cubic graph, but let's just pretend that we don't know this negative portion of that. So let's say we only know this bit of the graph. So by the way, this works the other way. So anyway, yeah, just never mind. Let me show you this approach. So now if you want to know that, this always works for odd functions as well. So in order to find the negative portion of that, what we should do is that first of all, we rotate we reflect this portion, the positive bit, through the y-axis. That's the first thing we do. So if we do that, we will get a quadratic graph. And then we reflect this through the x-axis. So basically we have two reflections. So first through the x-axis and then first through the y-axis and then through the x-axis. And the second one is always the one that gives us the correct shape. Yeah, so again, the approach is very similar to the case when we have even functions, because in even functions, we do that by simply reflecting the positive portion through the y-axis to get the second half of the graph, whereas in odd functions we have to do two reflections. Of course, you can use this definition which is related to rotation, but I think many mathematicians prefer the first one, which prefer this one, which is about two reflections. And in this one, you reflect the positive portion through the y-axis first, and then through the x-axis. And yeah, so that's all I wanted to discuss in this video. And in the next video, I'm going to solve some examples in which we are supposed to find which of the given functions are even and which of them are odd, or if there is a third case. That's it for this video. So if you enjoyed this video, please give us a like and subscribe for the future videos. Good luck.